So my technology is related to the, it is basically MRI contrast agent. We already know that what is MRI contrast agents. MRI, it is a very useful techniques for medical diagnosis, and MRI is now becoming very popular for this medical diagnosis purpose. But there are some issue with the available MRI contrast agents. So normally in market, if you see, there are basically MRI contrast agents which are manganese and gadolinium based, which are T1 contrast agent, means which increases the brightness, whiteness of a MRI image. If you see that image, if you use MRI contrast agent to for producing the image, it gives some whiteness or darkness. Without contrast agent, there is a less contrast in the imaging. So when there are some difficulties with manganese and gadolinium based contrast agent, because those are toxic and they have some drawbacks in vivo use. So people are now shifting towards the T2 contrast agent. T2 contrast agents are basically it increase the dark contrast. Okay, so and T2 contrast agents are normally iron oxide based contrast agent which are spy on super paramagnetic iron oxide nanoparticles are normally used T2 contrast agent. And these super paramagnetic nanoparticles are, they have some interesting properties, because if you apply magnetic field, they show magnetic properties. But if you if you remove the magnetic field, they will disappear. There will be no magnetic properties. And because of this, people are using these super paramagnetic iron oxide nanoparticles as a T2 MRI contrast agents. But this, if you we have to have super paramagnetic property, then we have to compromise with the magnetization. And super paramagnetic particles are very fine particles. Because of that, these are having high Brownian motion. So these are some things we have to compromise if you use super paramagnetic iron oxide nanoparticles. So there is a solution. If you what is the options to overcome these issues? If you make some cluster of magnetic nanoparticles, and this cluster should have also super paramagnetic properties. So people are now doing this research around now doing clustering of nanoparticles, and other options are obviously functionalization of nanoparticles, magnetic nanoparticles, with some suitable functional molecules which also increase the contrast efficiency. But the second option, clustering, is very fruitful. So our research is basically to develop a dense cluster of magnetic nanoparticles. If you see in whatever the patents or papers or the materials are there, they are not very dense clusters. If you make the dense clusters, it gives more contrast efficiency to the cluster space magnetic nanoparticles. So our research is basically to develop a dense cluster of iron oxide nanoparticles. From starting with iron oxide nanoparticles, we have used some biocompatible host material which are of submicron size silica spheres, and these silica spheres are biocompatible and they are entrapping the particles inside those pores. Our novelty is the developing a dense assembly of magnetic nanoparticles by efficiently entrapping the magnetic nanoparticles inside these silica beads. And during this process, nanoparticles are also shifted to from hydrophobic initial phase to hydrophilic phase, because hydrophilicity is the requirement for biomedical application. So this is our main novelty of our invention. And and this product what we have developed, if you we have seen that this is cost, if you see per 500 mg, it is around 200 rupees. And our technology is at TRL level 4, and we have applied patent for this technology, and it is we have submitted the FER reply for this patent, and it is going to be hopefully going to be patented soon. So these are some images. We have done some in vitro image of contrast efficiency for measurement. We have seen that after clustering through our process, MRI contrast relaxivity has improved 2 times from the starting with the pristine nanoparticles. So these are some phantom images we have taken. We have done the biocompatibility assay also for our samples using these cell lines. And these are another system which is iron platinum nanoparticles also. We have done some in vivo analysis for this MRI contrast agent. And if you see the market, addressable market of MRI, it is expanding very rapidly. And in India also it is expanding because people are now interested in developing indigenous MRI machine in India, but still we are lacking of good MRI contrast agents. Still MRI contrast agents, whatever they are, these are imported from outside. So we hope our technology will be indigenously developed MRI contrast agents. So for commercialization, transfer of technology, we have to follow the IPR agreement of Tezpur University. If anybody is interested in our technology, and definitely we need to scale up our technology. For this, we need in the help of industries to scale up the technology, scale up the amount of contrast agents, because we have done this thing in laboratory scale only right now. So these are some right now from tier level 4 to 9, we may require around 6 to 12 months, and we need funds for this for this to achieve that thing. And these are some equipments we normally use in our laboratory. If we have to, if anyone interested to develop this material, this minimum infrastructure is required. Thank you.